I want to start by thanking Aris for his talk, and his work and his book has been an inspiration for my graduate work throughout various projects. In the second part of this webinar, I'm going to talk about some of the ongoing work in our group as the MIT Concrete Sustainability Hub. So when we're talking about natural hazards, buildings and communities are inseparable from each other, but the way that loss assessment or risk assessment is often set up is that we analyze structures either in an isolated form, or if we're talking about stuff on a community scale, we assume that all of the buildings perform the same and characteristics are distributed uniformly. So in other words, the standards for loss estimation currently overlook variability within communities, but it's clear to see through photos and through our lived experience that not all homes and not all people are affected the same. Our goal at the Concrete Sustainability Hub is to create the most comprehensive framework to assess costs and impacts associated with the full life cycle of the built environment, specifically buildings and pavements. And our research is mostly funded by the Portland Cement Association and the National Ready Mix Research and Education Fund. In a broader scheme, it also relates to the Sustainable Development Goals, as one of these goals is to create sustainable cities and communities. And a major emphasis by the UN Sustainability Goals too is disaster risk reduction. So talking about three pillars of sustainability, there's economic aspects, environmental aspects, and sustainable social aspects that lead to a sustainable community and built environment. And we've identified gaps related to the quantification of each of these pillars. I'm specifically going to talk about projects that I have been involved in. So in one of those projects, we found that the benefits of hazard mitigation are vastly underestimated. And this has been published in a journal with the American Society of Civil Engineers. And some of our ongoing research relates to quantifying how hazard repairs play in the life cycle embodied carbon of buildings, as it's currently not quantified, but creating scalable ways to quantify that would also allow us to evaluate hazard mitigation as a form of carbon mitigation. So embracing both the resilience and sustainability perspectives in this assessment. We found that carbon uptake is also not captured in the life cycle embodied carbon, and we're working on doing that in a scalable manner too. And on the social aspects, we've found that hazard repairs aren't contextualized for the demographics that are most impacted by them. And we're creating more specific detailed methods of pinpointing which demographic and socioeconomic characteristics map to higher levels of risk exposure. These are some images from Netflix's Explained episode on hurricanes, where they make this point about federal agencies having a limited amount of funding, and they often have to decide between mitigating, for instance, a higher income community and a lower income versus a lower income community, where if they mitigate the lower income community, and here they symbolize it with a seawall, then it might result in higher monetary damages because higher value properties are exposed, but we're protecting the community that might not have the resources to bounce back on their own. Whereas if we do it vice versa, we might be mitigating a higher level of monetary damages, but inflicting damages in a community that might not have the same resources to bounce back. So overall, our goal is to aid stakeholders in taking climate action by producing models and guidelines that lay out the intended and perverse outcomes of design and policy decisions. And I loved Aris's point about assessing buildings should not be a mini thesis. For me, it is my thesis, it's my full-blown thesis. But the kind of tools that we're trying to create and put out there, we're trying to produce stuff that is easy to apply, that is accessible, and that is streamlined. So you can get results with limited amounts of information too. It's also important to recognize that there is a plurality of stakeholders. So we need metrics that are versatile, that can refer to the needs of different decision makers, like designers and builders, or the homeowners themselves, or the emergency managers. I'm going to start by talking about our work related to evaluating the benefits of hazard mitigation. And this is in a paper, and our key result is highlighted in the title of the paper too, which is discounting neighborhood texture leads to undervaluing wind mitigation, particularly in hurricane-prone areas. And the paper highlights our results for the state of Florida, but we've done this analysis for all 22 states and the hurricane-prone regions along the Gulf and Atlantic coast in the United States. So texture refers to the density and the configuration of buildings in an area. And the density of buildings is captured to some extent in the way that we currently calculate wind loads and design wind-resistant buildings, but the configuration is assumed the same. So for instance, these two neighborhoods that we see on the screen are both dense areas because they're suburban areas. But as you can see, it could be more disordered versus less disordered and more grid-like. And either of these configurations lead to different levels of wind load amplifications or reductions. Even neighboring communities can have vastly different textures. So these are examples of 3 census tracts that are right next to each other in Miami-Dade County. And the one on the top is the one with the highest level of disorder, as well as the one with the lowest density. So the one on the bottom is the lowest level of disorder and highest level of density. And applying an empirical relationship that was developed at the CSHub to calculate the maximum drag coefficients for each individual building in a study area, we found that the area with the lower density and the higher disorder has maximum drag coefficients that imply wind load reductions, while the denser areas with a lower density have drag coefficients that imply wind load amplifications. The orange, reddish colors imply potential wind load amplifications as they correspond to drag coefficients that are above what we've assumed to be the design standard. And in our case study relating to the impacts of texture and its impacts on wind losses and the benefits of mitigation against these losses, we had 2 sets of stakeholders in mind. One, the designers and builders, which might be interested in the drag coefficients and how that affects the design of structural elements. And the other is emergency managers, who are more so interested in the costs of the expected losses and the costs related to mitigating or not mitigating. And the mitigation measures that we've considered in this study are ones that could be applied on retrospect as well, like applying shutters on windows or reinforcing roof-to-wall connections with straps. And we mainly considered residential buildings in this specific study. And we evaluated the expected annual benefits of mitigating, comparing an unmitigated case to a mitigated case which has lower expected losses. And then from that, evaluated additional expected annual benefits, calculating the expected benefits in a case where we're accounting for texture versus a case where we're not accounting for texture and calculating losses the more conventional way that we see in tools like FEMA's HAZUS. And these results are available publicly on our texture dashboard, where you can view the drag coefficients for different areas and zoom into your specific zip code. For instance, we found that wind loads are underestimated in 25,000 communities, where I'm using community here to refer to a census tract. And wind mitigation is undervalued by orders of hundreds of $billions a year when you sum it up on state level. And you can find out more by reading the paper or checking out our dashboard, where you can play around with the results yourself. With our methodology, we're aiming to accommodate for variations within communities, and different characteristics go into something like a loss estimation or a benefit evaluation. By accounting for texture and calculating wind loads on building-specific level, we're incorporating a high level of spatial resolution into our model. And then we can combine that with information about the occupancy type, building type, or level of mitigation to evaluate expected damages. And then we can convert those damages, which are often in terms of a value like percent replacement cost, into monetary damages in terms of dollar values by incorporating information about property value, replacement costs, or if we want GHG impacts instead of dollar values, than the respective replacement impacts. With both the costs and the impacts and other indicators, we're achieving life cycle thinking within this risk assessment sphere. And then combining that with information about demographics and housing trends, we're adding additional context into who is affected by these increased costs and who's affected by these increased GHG emissions. And this latter piece is what I'm going to talk about in the rest of my presentation. But I'd be happy to answer questions or follow up with you guys if you're interested in the GHG accounting aspect of things. These variations within communities, we're characterizing them based on statistical analysis and previous research that was done in the hub. So we start with the baseline of FEMA's HAZAS tool, which is the current standard for emergency managers throughout the United States. And then add an analysis of census data, energy data, which gives us an understanding of the distribution of occupancy types, how that relates to building characteristics, as well as other monetary aspects like the property value, as well as demographics is also found from the Census Bureau. And we're incorporating various thesis work from researchers that have worked or currently work at the hub. And then moving on to our social vulnerability work, we're using a method from transit mode choice modeling called iterative proportional fitting, where based on a broader set of microdata, we can derive relationships between, for instance, occupancy types and income brackets, as well as relationships between indicators of social vulnerability in those income brackets. And then on more specific levels like census tract or census block, where we don't have the same level of detailed data because of privacy issues, but we do have summary tables, we can localize these relationships to signify specific census tracts or census blocks. So for instance, on state level, 8% of buildings might be of occupancy type 2, which in this model specifically, that refers to mobile homes. But we might be looking at a census tract that doesn't have any mobile homes. So that would get adjusted. And the distribution of the other occupancy types would also be adjusted to resemble the summaries within these locations. And the stakeholders here, since we're again working with expected losses and monetary damage, we're hoping that it's of interest to emergency managers, and there is an increasing trend in wanting to account for social vulnerability in the way that, for instance, hazard mitigation funds are distributed. And we're hoping that the metrics that we're deriving in our studies aids that kind of effort. But we're also interested in providing a metric that is meaningful to owners and tenants of buildings who will be making decisions based on how much of their annual income is going to be spent on expected losses versus if they mitigate. Again, our case study, we took Miami-Dade as an example because we were looking at hurricane wind damages. And of the 800,000 households in Miami-Dade, we found that 100,000 are exposed to financially challenging levels of loss risk. And we calculated that based on expected losses divided by the estimated household income for each simulated household, and seeing how many of those exceeded a third of annual income and exceed expected hurricane repairs. And since we're retaining the information about demographic and socioeconomic characteristics, we can observe, for instance, how prevalent a characteristic is among the county population versus the subset of high exposure, highly exposed households. In this example, I'm highlighting households that are below poverty. When you look at these values in terms of percentages, there's a clear difference between the overall prevalence of below poverty households and the prevalence of them among households that are exposed to financially challenging levels of losses. And if we divide these two values together, we could take that as a measure of disproportionate exposure. So it's prevalence in the highly exposed households divided by the overall prevalence. And then we can map that for other indicators as well. For our study, we focused on indicators that build up the CDC Social Vulnerability Index because these are recognized throughout emergency management and other industries as well. And we found that each of these indicators correspond to a ratio that's larger than 1. So households that are identified as socially vulnerable are also at higher risk of financially challenging levels of losses. And we can take this a step further and test out case scenarios where we have different levels of mitigation. Again, considering the same mitigation measures and same building types. And we can evaluate the performance of the current housing stock. So we can look at a case where all the buildings have these mitigation measures and are fully mitigated versus none of them have these mitigation measures. We found that applying the mitigation measures listed, 70,000 households could be removed from financial burden. We could call that the avoidable financial burden. And in our current estimate of the number of households that are in financially challenging levels of risk exposure, 55% of this avoidable financial burden remains in the county. So in the current performance of the state of the housing stock in Miami-Dade, only 45% of benefits, of potential benefits are being reaped. And there's a similar picture for monetary damages, as well as $2.6 billion of monetary damage could be prevented by applying these mitigation measures. And 47% of this potentially avoidable monetary damage remains in the county. So we're achieving only a little more than half of what is very much achievable. And we could use this analysis to inform future strategies for retrofitting homes. In the next slide, I'm going to highlight 2 strategies, which are more of the puristic strategies, where we would rank homes based on the losses in terms of percent income, take the highest, then second, then third. And the second strategy is ranking them purely based on the monetary damage or the dollar value of expected losses in the household, and mitigate them based on that prioritization. In our current estimate, so we drew an equivalent of, in the current estimate of losses, that's equivalent to 20% of homes having all of these mitigation measures applied. And that covers a little more than 40% of avoidable financial burden and a little more than half of avoidable monetary damages. But what could we do with these 2 strategies that I mentioned before? If we prioritize homes based on their monetary damage, we could achieve 100% of avoidable financial burden, and with around 13% more of homes being mitigated, we could achieve the majority of avoidable monetary damage if we cut it off at 75%. Because for 100%, we would have to mitigate close to 100% of homes, as there would be some residual loss. With strategy 1, we're prioritizing homes based on their financial burden. We can achieve the avoidable financial burden a lot faster with a limited amount of trade-offs in our performance in terms of avoidable monetary damages. So what this highlights is if we use a combined strategy between these 2 things, we could achieve great performance in both of these metrics only by distributing these funds and mitigating homes in a more intentional manner. So as I highlighted, it would be around like 13% more of homes being mitigated to achieve the majority of avoidable monetary damage. And if we could use a combined strategy where we mitigate all of the homes that could be removed from financial burden and then use the rest of our funds to mitigate homes based on monetary damage, we could achieve the same level of performance with around 14% mitigation. So that's just 1% increase. We're working on putting all of our research into our online dashboard, which currently includes texture-informed drag coefficients, as well as mitigation benefits evaluated, accounting for texture, not accounting for texture, with a breakdown of different occupancy types and the results that we're getting if they're mitigated or unmitigated, which is accessible on the website. And we also have research briefs, aside from our papers, that summarize our research in a more practical and hopefully accessible way, which also could be accessible on the CSHub website. And with that, I want to open the floor to questions, and please feel free to reach me at my email address, which is my name, bensu@mit.edu. Thank you all for attending our webinar today.
All right, thanks very much, Bensu, for this interesting presentation and sharing your results and research outputs about how to build our community more resilient and what's the sustainability impacts from the cost, environmental, and social perspectives related to the resilience of our building community. We have received a lot of questions that I doubt if we could answer all of them during our remaining timeline. But if we didn't get a chance to answer your question, please feel free to email us your questions, and then we would definitely follow up with that and provide the answers. I'll forward the questions to Aris and Bensu to make sure that they are well addressed here. But let's start the question here. First question for Aris. What's your opinion on what it will take to compel federal, state, or local agencies to adopt a set of responsible, resilient design and construction policies?
A big disaster like we had in Miami in '92 with Andrew. But as we've seen later in later disasters, you know, that's even that it may not be enough. And many people don't know that in the case of Miami, a lot of the discussion on resilience and what the standards should be has started like 5 years before. So as we know, disasters are a very difficult period, you know, to start having that discussion, you know, because people are consumed with trying to get their homes back together and their communities back together. So unless communities have that discussion beforehand and basically have the higher standards on paper, and it's just requiring the politicians' votes, you know, it's hard to get them implemented. So the groundwork has to be done, you know, while things are good. And then when the disaster happens, you know, the pressure has to be placed on the officials to just push the button. Unfortunately, we're seeing that, you know, I have the case of Mexico Beach in the Panhandle. They had a category, you know, 4 or close to 5 hurricane, and they only raised the wind standard from like 130 to 135, which to me is a joke. So, you know, they should have raised to the South Florida standard of 165, 170. So basically, you know, you have people saying, well, you know, the builders are lobbying to keep the standards low, and the politicians are saying, well, if we make them too high, then people won't be able to afford them. Again, short-term thinking, which again will expose those people when they rebuild to the same risk of disaster in the future.
Excellent, thank you. Next question, perhaps for Bensu. From your presentation, we realized that the city texture or the urban morphology can affect the wind load. Could you please expand a little bit on the building density relationship with the wind load increase?
Yeah. So currently in the wind loads, density is captured through exposure categories, and each category is assigned one factor. So a category includes all suburban areas, all urban areas, and we don't have detail about the configuration because these coefficients were calculated based on experiments with very regularly placed objects. But the research that we've done has found that we can simulate things with disorganized, realistic configurations, and that configurations that are close to grid-like but not perfectly grid-like lead to channels where wind loads are potentially amplified through this tunneling effect. I hope that answers the question.
Yes, thank you very much. Another question for Aris about building resilience index. A B-level hospital could be an A+ level office building. How would BRI apply and consider this variation and importance to be fair for different types of building applications or programs?
Yeah, this is an important point because, you know, I need to stress that BRI is use blind. In other words, it doesn't look at the use of the building. It rates basically, for the hazards that are applicable in that location, does the building have particular measures? Now, let's say a hospital turns out to be a B. That's not a good thing. You want a hospital to be an A or a double A, if your home turns out to be an NR, maybe you as an individual want to be in a B home. I mean, personally, I'd like to be in an A home or a double A home, because the home is so important to me. So really the rating is blind. I mean, it's a technical rating. It's like the body mass index that doctors use for measuring. They don't look at your income or how tall or what gender you are. They just tell you your BMI is this. Deal with it. BRI is kind of a similar technical metric, but how we use it and how we make decisions, obviously, it's an important factor in saying, I want this building to be at this level,
Mm-hmm. Yeah, this is very important that we would like everyone and every building to be A+. And maybe that's the important aspect from the structural and envelope and different properties of the buildings to be included in the resilience assessments. Thank you very much, Aris. Next question for Bensu. How soon will your research idea be developed to the point where municipalities could incorporate resilience in their bylaws?
Well, I'm planning on defending this summer, so hopefully the finished product will be this summer. But in terms of formatting it in reports that could be more helpful for federal, state, or local government, we've had different governments reach out to us for collaborations on this aspect. We're going to make the tool publicly available. So if you want to look at the social vulnerability of a specific community, you can. And then for the interpretation of those results, I think that it would be most useful if it was done in collaboration, in communication with what the needs are of that specific state or that local community. In terms of the tool development, though, we're aiming for end of summer or early fall this year.
Awesome. Thank you very much. It's now 12 p.m. We are running out of time. So thanks everyone for joining this presentation. Have a good rest of the day.